Now let me show you one example. Suppose we have a transfer function with a polynomial a with 1 minus 0.9 z inverse. Then have the b is just 0.5. The time delay here is 1. Now let's find the one-step ahead predictor using both approaches. So if we use the first approach, so here the time delay is 1. Then we have the so we have 1 minus 0.9 z inverse. So k, so one step ahead predictor. So k is 1, so be y hat t plus 1. So right hand side we have the time delay is 1. Then b is just 0.5. Then we have u hat to t plus 1. So if we expand the left-hand side, so the first term will be y hat t plus 1. Then the second will be 0.9. So the z power negative 1 is represent time delay. So we have the yt here. Then the right-hand side, we have 0.5. Then z inverse is represent the time delay. So we have the u hat t. Okay, so this will be, so prediction of yt plus 1 condition on t will be 0.9 yt plus 0.5 utt condition on t. Okay, as you know, so yt, so it's a past information, it's a past information, past measurement. The utt is a future input. So we use a past output and a future input to predict the future output at one step ahead. Now let's discuss the second approach. In the second approach, we need to solve the Diophantine equation. So the order of the ek, so k here is 1. We have e1, we have f1, we have z power negative 1. So the order of k, the order of e is k minus 1. So k here is 1, so therefore the order of e will be just 0. So therefore the e1 here is just a constant. So therefore it's e0. We have e0 here. So e0. So times a, so a will be 1 minus 0.9 power of negative 1. Then the k here is 1 because it's one step ahead predictor. We have z negative 1. So the order of f is n minus 1. So here, so we can see from the polynomial of a, we know that n is 1. So if n is 1, so the order of f1 is n minus 1. So therefore, the order of f1 is still 0. So therefore, f1 is also constant. So here we have the f0, then it's 1. So to solve this equation, we just need to compare the coefficients of the polynomial on both sides. So for the constant term, so the left-hand side we have e0. Then, so this is the only constant term. So the right-hand side constant is 1. Then for the coefficient of polynomial, so the z negative 1, so we have e0 times 0.9, so multiply 0.9, so plus f0. So this is the coefficients of z power negative 1 on the left-hand side. So on the right-hand side, So it will be 0. We don't have any z negative 1 term, therefore the coefficient is 0. Then by solving these equations, we have the E0 is 1. Then so here should be in the negative. Should be negative because we have the negative here. There should be negative, so E0 times 0.9. So therefore we solve for F0. So F0 will be just 0.9. Okay. Then by using this formula, we know that K here, so K here is Y, K is 1. So Y T plus 1 can have T. So the F, so F is point, F1 here is 0.9, so F0. We have 0.0, so YT, then have Z power of 1. So the E here, so E1 is just E0. Then it's just 1, then have the B, just 0.5. Then U hat UT plus 1. Then it will be 0.9 YT plus, because the Z inverse is represent time delay, so therefore will be 0.5 will be U. The time delay of UT plus 1 will be just UT, so be the UTT. So as you can see, by using the two different approaches, we have the same result here. The prediction of YT plus 1 can T will be 0.9 YT, so 0.190 plus 0.5 for UTT. So even though we use two different approaches, but we end up with the same result.